So on Thursday last week, you learned about the distance measurement. So you learned about what is Manhattan distance, Euclidean distance, cosine, similarity. So today you're going to learn about the clustering, which is about partitioning, and we learn one algorithm, which is K-means. If the time is enough, we will learn about the clustering performance. So we can look at the clustering from different data set. Yeah, you can see from the phone data, you can also see from the iris data, you can also see from the applying data set. Now let's see. Partitioning algorithm. So what is the meaning by partitioning algorithm? The partition. Partition means we have a bunch of data. We want to do partition. So partition means we want to make some splitting. We want to make something into maybe two groups, or we want to partition. Let's say I have a box. Okay. So I want to do the partition into four. Then I can do partition like this one. Okay. So partition means making some clusters, making some groups. And in order to make the groups, let's say I have a database D, and then I have n objects. So n object means we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the object means the rows. So I have n rows or n objects. I want to partition it into a set of k clusters. So let's say if k equals to 2, then I want to make 2 groups. So this idea is using the sum of square distance. So if you look at the distance measure, we have the distance measure like Manhattan. We can also use the distance measure Euclidean. And we can also have another kind of measure. We call it sum of square. So the basic concept here, we can use the sum of square distance, and it should be minimized. So the number should be minimum. So let be P the object point. So here P is the object point, and then Ci is the centroid or matroid of cluster C. Centroid. Centroid means the center. So we want to find the center of a group. And we will do the subtraction. K is given. So usually K is a number 2, 3 until n minus 1. So if K equals to n, then it means K equals to the number of the data. So there's one algorithm, they call it K-means. So it has been proposed in 1967. It was very old algorithm. So its cluster is represented by center of the cluster. So we need to know what is the centroid or what is the center, and then we check whether the distance from the center is minimized or not. So K-means is the name of the algorithm. We call it K-means clustering. And the algorithm is implemented in 4 steps. So the first is we will partition the objects into k non-empty subsets. K. K is any number. Let's say you have k equals to 2, then we want to make it into 2 groups. If you have k equals to 3, then we want to make it into 3 groups. And then the second step is to compute the centroid. The centroid means the mean point. And assign its of the object. The step 4, go back to step 2. So go back to step 2. Stop when the assignment does not change. Now, let's see. I have the phone data. If you still remember, this data is a data in the database that exists without any labels. So we do not know what is the label, whether it is good phone or bad phone, or expensive phone, cheap phone. So we just have this number. Battery means how many hours the battery lasts, and then the camera means the camera pixel. Now, the task is given k equals to 2. So I know that k equals to 2. Find the relevant clusters. So how can we find the clusters? Okay, now let me show you how we can calculate it. We will do several iterations. We will do the iteration 1. Based on the data, we can plot. This is the visualization. The data number 1 is here. Let's say maybe this is the battery, and this is the camera. So the data number 1 is here. 12 for the battery and 4 for the camera. The data number 2 is here. 76 and 60. And so on. Now, we have the n equals to 5, and we will cluster with k equals to 2. So how can we do for the first one? At the first time, we need to calculate the center point. What is center point? We need to find the center point. So the center point is, let's say, for the first iteration, I will do the grouping number 1, number 2, and number 5. So I assume that we are in one group. Then I can calculate the centroid. The first column. The first column is 1 and 2 and 5. So it means 12 plus 26 plus 22 divided by 3, because we have 3 objects. So this is the centroid for the column battery. What about the centroid for the column camera? So the same, we have 4, 16, and 12. Then we have 4 plus 16 plus 12 divided by 3, because we have 3 objects. Now you can see the centroid is 20 and 10.67. So 20 is the centroid for the battery, and 10.67 is the centroid for the column camera for the object 1, 2, and 4. The second one, oh, sorry, I missed the animation. So the centroid number 2 is the data 3 and 4. We can do the same. 9 and 8. So we have 9 plus 8. We want to know the center point. Center point is 9 plus 8 divided by 2. For the data camera, so we have 9 plus 7 divided by 2. Then we get this is center. 8.5, comma 8. Now, we want to find the sum of square distance. What is the sum of square distance? It is to get the distance from every object. P is every data object minus by the center point. So let's see. I want to know the cluster 1. Okay, so this is the cluster 1. The cluster 1, I have 1, 2, and 5. Then it is 12 minus the center point. 26 minus by the center point. 22 minus by the center point. And then we do the square. So every of this one, we do the square. Plus, so we will do the summation for all this one. And then we do for the second column. 4 minus the center point. 16 minus by the center point. And then 12 minus by the center point. Then we will do square and do the summation. So in total, we will get this score. Okay, in total, we will get 200.11. What about cluster 2? So cluster 2 is the green color. It should same. Okay. So we will do the subtraction. 9 minus by the center point. And then 8 minus by the center point. 9 of the camera, we will subtract with the center point, which is 8. And 7 also will be subtracted with the 8 of the center point. So we will do the square for every subtraction and we will do the summation. Okay, so that's the meaning by this formula. So at the end, what is E? So we want to do the summation for this one and this one. So 200.11 plus 2.1. Then we will get the value as much as this one. So the E, or we call the expected L, or the expected distance, is 202.61. So is it good or bad? We do. Good. Do you think it's good? So we need to do more experiment because there might be different kind of group. So the next experiment is we call it the iteration number 2. In the iteration number 2, we will write another kind of centroid. Now let's see if the centroid is like this one. If I put 1 and 3 and 4 in the same group, and if I put 2 and 5 in the same group, so I can calculate again the centroid. The centroid of 1, 3, and 4. Okay. 1, 3, and 4. Sorry. 1, 3, and 4. So it means 12, plus 9 plus 8 divided by 3. And then 4 and 9 and 7 divided by 3. So we got the centroid for the cluster one here as much as this one. And the centroid for the group 2 cluster 2, which is 2 and 5. So 2 and 5, 26 plus 24, 22 plus 26 divided by 2. And then 12 plus 16 divided by 2. Then we got this centroid. After we got this, then again we will do the sum of square distance. This is the sum of square distance. Using the sum of square distance, like the graph is 1, we want to check the cluster 1. It means the object 1 and 3 and 4. So object 1 is 12 minus by the centroid. And then object 3 minus by the centroid. And then object 4 minus by the centroid. Object 1 is the camera minus by the centroid. Object 3 minus by the centroid. And then object 4 minus by the centroid. And then every of this will be squared by 2. So you will get the result is 21.68. And the cluster 2 is the same like this one. So we will do the subtraction. 22 minus 24 square, 26 minus 24 square, 22 from here, 26 from here, and then 12 from here, and 16 from here. Then we will get this value. Now, if we do the summation, 21.68 plus 16. Now, the value is 37.68. Is it good or bad? So now we can see from this figure. If you look at this figure, the distance is shorter compared to the previous figure. Because the distance, or because this is the error, is smaller from the iteration 2. So since the value is smaller than the previous iteration, we select this option, or we call it select the minimum. So this iteration, not only 2, it can run again. Iteration 3, iteration 4, iteration 5, iteration 6, until we find the minimum. If you reach the minimum, then stop. So that's the minimum by the image. Now, we need to check the performance. How can we know whether the data, whether we do the clustering, whether the clustering is good or bad? So the previous section, we learned that we need to find the minimum error. If it is the most minimum value, then that is the best. But there is another way to do the performance measurement. In order to measure the clustering quality, so there are 2 methods. The first method is extrinsic, and the other method is intrinsic. Extrinsic means we want to do supervised. Do you know supervised? We have learned 2 things. supervised machine learning and unsupervised machine learning. What does it mean by supervised? It means we have the target or the label data. For example, you know the data in iris. What is the target? The iris dataset. The target is the flower name. So we have the petal length, sepal length, petal width, sepal width. So those are the variables, and we want to predict the flower name. You still remember the advertising dataset? So what is the target? The target is the sales. We know the spending on the TV. We know the spending on the radio. We know the spending on the newspaper. And we want to predict the sales. So those two data are supervised machine learning. So those two data belong to supervised machine learning because the data includes the target. But what is unsupervised? In the unsupervised, we don't have any target. For example, the phone data. So we have only the observation. We have only the information about camera and battery. But what is the task? What would we do with this data? We do not know. We do not know whether they have the price. We do not know whether it is about the quality of the food. We do not know what we want to do. So we just have the data. So because this is unsupervised machine learning. And in this unsupervised, we want to make groups. After we calculate the distance, we can find, okay, the group is the high quality phone and low quality phone. If you look at this one, if you look at this one, then we can say maybe this is the high quality phone. The battery is long, and the camera is also good. The camera is high risk. In this case, this is low quality phone because the battery is only 12 hours, 9 hours, 8 hours. And the camera is only 4 and 9 and 7 megapixels. So I can say, let's say this is the cluster 1, this is cluster 2. So we can define the cluster 1 is low quality phone, and the cluster 2 is high quality phone. So we can make our own class, or we can make our own unit. So this is the label based on our result in the classroom. This is what we call unsupervised learning. We don't have the label, and then after we do the clustering, we can get the label. Now, the problem is, if we have the data, sometimes we can have the supervised or the ground truth is available. The ground truth means we know the label, So if we know the label, let's compare the clustering against the ground truth using certain clustering quality measures. So we can use precision and recall metrics, or we can use utility. Some of the data might be unsupervised. It means the ground truth is unavailable. So we do not know what is the exact target, what is the label, what is maybe in iris, we don't know the flowering. In the sales data, we do not know what is the sales. So we need to evaluate the goodness of clustering by considering how well the clusters are separated and how compact the clusters are. We will use some measures like silhouette coefficient. So let's see how to measure with the precision and recall. Do you still remember precision and recall? We use this one in the classification. In the classification, we have precision and recall. And for the extrinsic or the supervised, when the ground truth is available, so we want to compare a clustering against the ground truth using a certain clustering quality measures. Let's see this one. In the supervised learning, we know that there is a category data or category limit. This is for the classification. The ground truth is available for evaluation. If the sample length is 5.1, if the sample width is 3.5, and the petal length is 1.4, and the petal width is 0.2, the flower name is iris petal. So this is the supervised. But now I am going to put it as unsupervised. Unsupervised means I will delete the column iris. So I will remove the category label, and then I will check. I will build model. So the model can classify the new unavailable data. So using this data, we know there are three flowers. There are three flowers. We know there are setosa, versicolor, and virginica. Now, let's say if I want to make three groups from these flowers, how can we make the groups? If we perform the chemistry, is it good? Can we make a good model? Then using the chemist result, so this is the clustering result. Using the chemist, I can get this result. So the flower number 1 and until number 4, number 1 until number 4, okay, they are in the cluster 3, C3. What about this data? This data belongs to, okay, cluster 1. What about this data? This data belongs to, okay, one of them has been cited in the cluster 1. So the clustering result or the chemist gives something wrong in this data. This is not wrong, but maybe this is because of the distance. The distance is somehow ambiguous. The distance might be very low, but actually it is belong to Virginica. So the algorithm might have some errors. So we need to calculate this kind of errors. If the error is small, then maybe the algorithm is good. But if the error is high, then we need to find a good or a better algorithm to make clustering. So let's say I'm just using the k-means and I want to measure the performance. How to measure the performance? So I can make this kind of table. So the iris setosa, this is the iris setosa. 0 has been noted as C1 and 0 has been noted as C2 and there are 4 noted as class 3. What about the basic color? So the basic color, 4 of them has been noted in the cluster 1. C2 is 0 and C3 is 0. What about the Virginica? Virginica here. 1 is C1 and then 3 is C2. So we can see here in the C1 there are 5, in the C2 there are 3, and in the C3 there are 4. Now, how can we measure this performance? Then we can check based on the precision and recall. The precision means we will check the methods from the classification evaluation. If you still remember, in the classification, we learned about this one. For its actual class, okay, we call it this is the actual. We can consider the cluster that is most associated with it as the predicted cluster. So maybe the cluster is the prediction. This is the prediction class. Then you can calculate the precision for each of the flower and the recall for each of the flower. Now we can see the precision. It is the number of setosa in C3. So because we know setosa, most of them are in the C3. So this is the number of setosa in C3 divided by the total point in C3. The number in C3 divided by the total in C3. What about the precision in basic color? We want to know this is in the C1. Then we have C1 4 divided by the total point in C1. The total point in C1 there are 5. And then the Virginica, we want to check the number of Virginica in C2. So the number of Virginica in C2 there are 3. And then the total point in C2 is 3. Then this is the precision of setosa, this is the precision of versicolor, and this is the precision of vision. What about the recall? In the recall, we also the same, using the 3 flowers, setosa, versicolor, and virginica. For setosa, let's check. We know that the setosa is distributed in the C3. So the number of sentosa in the C3 divided by the total actual sentosa. So we have the sentosa is 4 and the actual sentosa is 4. And 4 divided by 4. The versicolor, the number of versicolor in CE1, and then we have 4 divided by the actual is 4. And the Virginica, the number of Virginica in the C2, let's say this is the majority, we want to measure it, and then we divide with the total actual Virginica, which is 4. So we got the value 0.75. The other method we call it purity. So purity means purity measures the extent to which its cluster contains data points from primary one class. So high purity score indicates that the cluster mostly contains instances in a single class. So we have the items in C1. The item in C1 is 5. The item in C2 is 3. And the item in C2 is 4. So for its cluster J, find the majority class within that cluster. So just find the majority. For example, for the purity C1, if we want to calculate the purity C1, the majority class in C1, the majority is the majority is 4. Okay. Here C1, the majority is 4. So we will use this 4 and then we divide with the total item in C1. For C2, the majority is 3. And we divide with 3. For the C3, the majority is 4. So we divide with 4. So this is the purity for its cluster. After we have this purity, we will calculate the overall purity. The overall purity, we can have this formula. The summation of Nj divided by N is the number of data that we have, multiplied by the Pj. Pj is the purity for every cluster. Since we know that the total data is 12, so 5 plus 3 plus 4, so the overall purity is 5 among 12 multiplied by 0.8. Where is 0.8? This is the purity. 1 is the purity C2. 1 is the purity C3. Then we can just multiply 5 divided by 12 multiplied by 0.8, the purity C1. And then 3 divided by 12, which is the total data, multiplied by 1, which is the purity of C2. And then 4 divided by 12 multiplied by 1, which is the purity of C3. Then we can get the value 0.9166. The high purity means the best clusters. So in this case, we can get the high purity. So this is the best cluster on this. Okay. Okay,
I will stop this one because
we need more time. Then